sound inferior to this place. I mean, every time we come here, it's so. First, let me pop this thing up. If it'll. Uh-oh, I went to the first slide. I'm sorry. All right, so I'm Kyle Buchanan. I'm one of the organizers. There's 3 other organizers who all stood me up today, so you're stuck with me. So obviously you're here for ES6, but just today I announced a really cool one with John Williams. I haven't actually met him yet, but he just reached out to me and said, hey, I've got this really cool presentation about light painting with robots and JavaScript. So he just actually gave this presentation up at a conference in New York. It's called like Bang Bang Con. I don't know if you've heard of it, but so that's coming June 17th at Dude Solutions. That's, this is Terry. That's for Terry Works. So that's in Cary. We try to keep going back and forth between Raleigh and Durham just to make sure we cover the triangle. No offense to Chapel Hill. And then I've got a couple more coming up. There's one about, I haven't got them on the schedule yet. So JavaScript security, which I know nothing about. Sounds like a pretty interesting topic. And then a guy that I just started working with at Red Hat, his name's Burr Sutter. He's got all of these cool ideas about, or with the Internet of Things. He's shown me demos with Raspberry Pis, with Bluetooth connected stuff, all done with Node. So look for that one, I think, in August. So yeah, I think Jason had a couple of things to say.
I'm Jason. I'm an engineering manager here at Bronto. I run the front end team. Most of my team is here. You probably talked to some of them. We handle all things HTML, JavaScript, UI, Melissa is our recruiter. She's trying to hire 30 engineers this year.
Yes.
106 people total. Which is almost. We have 267 people work here, so that's a third more. You may have read that we recently agreed to be purchased by NetSuite, which is an ERP company out of San Jose. Moving on to bigger and better things. So, if you guys are interested in jobs, front end, back end, Java, PHP,
Free beer.
Python. What's that?
Free beer.
Free beer. Out there, if you guys want some more. We don't know what the new benefits are going to be like, but they're awesome now and they're probably going to be awesome still. So appreciate you coming out and giving a talk. So we always love having trying to JS here. Thanks.
Thank you. So tonight we've got the people at NPM were nice enough to give Terry some t-shirts that we'll be giving away at the end, but I think Terry had a couple things to say about NPM.
In order to give it out, they want us to give us a little message. So basically want me to say that NPM is a company, which we probably all know. They now host private modules, so check that out. It's like $7 a month, and you can host private modules for your company, and that NPM loves you. So check them out. Check out the private modules. Stick around for
yeah, we actually have 2 women's shirts. We rarely get women's shirts, so we're happy to have those. Yeah, I don't know how many. There's a few women in the audience tonight, so you guys will have to fight for them.
There's also some stickers out there, so check those out.
Yeah, and then I have just a couple more announcements. I sent an email to everybody about NC DevCon with the early bird registration. I think that's now done. So now tickets are $200 a piece. I went to this 2 years ago, ended up sitting right next to Raymond Camden just out of the blue. I didn't even know who he was at the time, but now he shows up on my Google Now all the time. So that was cool to have those people that are in our industry right there at this event. And then, does anybody else have any announcements, job openings, anything that they'd like to promote? There's got to be something. There you go. Oh, and you're wearing a Polymer t-shirt. That's awesome.
So I work for a company called Proxies. We do business process management and workflow automation. We're looking to hire some PHP programmers. So hit me up if you're looking. I work at Windsor Circle. We actually use ES6 on the front end. We hire front end, back end in Python. We connect e-commerce to mails, ESPs like Bronto.
And you guys just did the Backbone presentation.
Yeah.
Yes.
Ben. He's
Ben. Yeah.
Here, yeah.
That was awesome. That was really good.
I work at AT&T. We got one spot on our team. We're converting one of our large applications to Ember and
really use, and we're expert to show us where we're being stupid. So, very interested talking afterwards.
Terry.
So I work at Dude Solutions, and we do Angular on the front end and some C# on the back end.
Way back there.
I work at Mark Logic. I work remotely, and we're very similar. Angular front end, looking for full stack.
Hi, I'm Mark. I work for Center Corporation, and we're looking for 2 senior software engineers. We do backbone internet on the front end and C# on the back end. So, if you're interested.
All right, so let's keep them going.
Sure. I work for Sugar CRM. My name is Matt, and I'm actually looking to hire a developer advocate. If you haven't heard of Sugar CRM, we're based in Cupertino, big PHP JavaScript application. But if you're familiar with the product, definitely can chat with you.
I'm Kian. I work at AdWords. Full-time developer, Rails, mid senior level.
All right, so has anybody released anything cool? Anything that they've been working on? Let's. I got my first application on the App Store. I have like 100 downloads between iOS and Android. I'm psyched. It's called Now Playing by Kiss and Make Apps. It's me and my wife. It's really silly. It's a phone gap application, but I'd appreciate the downloads. Anything else? All right, so, I'm sorry.
I'm Dan. I work at Amplify Education. It's actually right across the walkway. We're looking for a front-end developer.
All right, so if you're looking for a job, you're in the right spot. If you're looking to poach, you're also in the right spot. All right, well.
I have one thing. Project-wise, if like ES6 kind of things are your thing and you happen to love generators, I'm working on a framework using Koa to build like an MVC framework based on Koa. If you're not familiar, check it out. We'll actually cover or go over some things there. But if anyone was interested or loves generators and wants to work with that, and you also wanted to contribute to a project, let me know. I would love the help. So.
Okay, cool. Yeah, I think, Josh, you're going to take it away. He's got a lot of information. There's a lot of stuff that he could go deep on here, but I think you're going to try to hit a few topics. And then I think we're also going to be up for adjusting if we want to, if people are interested in something different than, I mean, it's ES6 related, but he has a list of what, how many topics?
Any topic.
No, how many topics did you have?
I think well, it's distilled down to like 11 now.
All right, 11, so there's 11 things. We'll probably try to do as many as we can. So, all right, thanks, Josh.
Cool. I'm going to turn this mic on. If I sense myself being too loud, I'll turn it off. Sorry in advance.
And I'm really sorry I went to your first slide without.
Can you all hear me? Is that okay? Not too loud? All right, cool. Great. First of all, I mean, I was really flattered to be able to like give this talk. I appreciate everyone's like willingness to show up and be interested in it. I have done as much research as I can, and I hope I don't say anything wrong, but if I do, feel free to raise your hand and correct me. Like, what we're here to do is like to learn, and I have no problem with us, you know, coming out with the best knowledge possible. All these meetups are like such amazing opportunities to learn something that's like something you'd learn at a code school or something that you have to teach yourself, but this is the best kind of environment for such a vibrant community of the Triangle to have, you know, 160 people just be like, yeah, I'd love to learn that. Like, let's all get together and like talk about that. So support your local meetup, you know, attend, bring more people, talk about things, work on projects. Thanks everyone for showing up. As Kyle mentioned, I tried to do the doodle poll and get some like testing about some concepts or topics. We've distilled that down to like 11. Before we start on each like section, I'll just ask if anyone's like really not interested in talking about a particular thing, because some of these like they're probably a little bit more apt to you just, you know, digging into on your own and like kind of figuring out what there is. Others, it seems like there's not much there, and then you read the documentation or the spec and it's just horrendous. So let's dig in. I thought about starting the presentation with the theme song to Dragon Tales, because it's kind of like we're kind of like traveling into this world of code that we can kind of write today, right? Because there's like Babel, and we'll talk about those tools. But really, it's like the dreamy world that I really want to write in today, which is impending, which is great. Like it'll be there soon. But just so we can start, I think there's a lot of like discussions going on, especially on Twitter and things like that. And I thought I'd just share a quote by our JavaScript overlord, Douglas Crawford, who's not necessarily the most excited about ES6. So I thought it might be just good to display that there are differing opinions about the things that are coming out in ES6. But the takeaway is really, this is one of the most widely used languages on the internet, and ES6 will be backwards compatible with every other engine that's still running it. And you want to give people features, and you want to give them like new idioms and macros, but there's usually a cost to that. And I think what we've ended up with this like ES6 specification is like, it's going to make our lives a lot easier. If you write JavaScript, you're going to like writing this more. It solves some problems that are really annoying to have to think about all the time. And the syntaxes are much cleaner, easier to read, more intuitive. So all in all, there will be cynics, and there are definitely places to criticize what has been added or implemented. But I mean, it's a great thing that's coming towards all of our development cycles. So this is a compatibility chart of the ES6 features in today's engines. If you didn't receive the memo, this is not ready in every engine yet. One of the most interesting things here is that it's one column Edge, like Edge.js, which is like this weird mix of .NET and JavaScript, has an amazing number of features supported. But what I'm really trying to show here is that if you wanted to write ES6 today, what you'll find is that in terms of code that you could write for production, Babel is still going to be the highest player, the best player in that game. And we'll talk about what Babel is, but Babel.js covers, it looks like, the number's not there, it's like 78% of the features that are in ES6 spec, which is great. And it's not the complicated ones, it doesn't do everything perfectly, but the team that's developing Babel has spent so much time testing out features and giving them to community and then having them sort of vetted and to see what their likelihood of succeeding or being adopted by the community is. So just know that a lot of things are missing. The next most important column I'd point out is like Firefox 39, which I think is like a canary build of Firefox. The SpiderMonkey engine has always been pretty far ahead in some of the ES6 features. So if you want to play with like proxies, some really interesting things, they've implemented a lot in those regards. So we'll talk about that a little bit more. So how can I even, some people in this room probably are writing ES6 today, and it's in their build system, and they have no problem with it, and maybe they have JSX in it as well. If you're just starting out and you're not familiar with how that works and you want to build system, basically there's a tool, Babel.js, and Babel.js is what's called a transpiler. That's going to take your ES6 code that you've been writing and do everything necessary to turn that into ES5 compliant code that you could run in a browser or any engine that supports ES5. It comes with a command line utility. So if you wanted to just pipe a file out and turn it into ES5 that you wrote in ES6, you could do that. It also has a module or a plugin for every build system out there, like Grunt and Gulp and Broccoli and who knows what else. And if you really wanted to test out while we're talking certain things and like play with a REPL, you can go to babeljs.io/REPL. More than welcome questions. I'll be doing a lot of text editing in Sublime, and I'll have a build there that I can just Command B, and we can see the results of the scripts that run. And that's also included in the Babel package. If you were downloading it with npm or something, you get a Babel node binary, which will run ES6 files, transpile to ES5, and then run them in your node environment. So, all right. So the first topic, I guess just if no one wants to hear about this, raise their hand. Great, that's fine. This was one of the highest rated things on the Doodle poll, enhanced object literals. Now, if you're not familiar, when you see the squiggly brackets and you're defining an object with its keys and values right there on the spot, and you're not using the constructor or anything like that, that's an object literal. Now, one pain point of JavaScript that you've probably all experienced is, well, what if my keys are dynamic? Like, what if I want to create an object literal, but I need dynamic keys or computed keys and things like that? Or why do I have to keep repeating myself for things? So basically, the features that will be implemented here are the ones that we've really hoped would exist for a long time. And it makes writing object literals and adding things and extending things much easier. This is basically a culmination of the things that are there. So pay no attention to this at the moment, but let's just say we have a function. That function it's stored in a variable. But here's my object literal, right? Now, the first thing that I'll point out is there's now a shorthand for defining properties with values that match the name of the variable. If I just want a say hello property and it to be equal to whatever value is at the say hello variable, I can do that with just putting say hello. That's kind of handy. I don't know how many people, like, I mean, I don't know how often that's like, oh, I really wish I could just do coordinate x. I don't want to write x:x variable. The next thing is method declarations on object literals. If you have peeked at what classes look like and things like that, you'll notice that this is very similar. Instead of having to write your typical ES5, here's my property, it's a property method, here's the function, you can basically shorten that down to this is my function, and here's the function body, which looks great. It's a little bit easier to write. And a lot of these things are just, hey, like, it's annoying to have to write stuff and be so syntactically correct all the time. So they're just conveniences in some of these cases. So. Here's another example. I don't know why this one was important. Pay no attention to that. Here's computed properties. Now, this is like, honestly, one of my favorite things in the whole spec. It gets so annoying to say, well, I know the name of my key, it's dynamic, it's stored in a variable, and I just want there to be an object that has that, and the value is different. So what you can write in between these brackets is an expression. Basically, it's going to turn that into your property at the time that this object literal is defined and evaluated. So in this case, I'm just making a string called prop underscore, and I'm doing some math, which is like really simple. You do whatever you want to do. But expressions are supported in there. I don't know how complex you could get, but I think you would know when you did it wrong. So also, getters and setters. ES5 getters and setters are kind of tricky. You know, some engines let you just write get and then name, and that's actually a property and it's a function. In ES6, obviously shorthand, you can just put get before it. You're still defining a property method, so it looks just like the other ones, and you can define it like that. Works similarly with set. So it looks just like that. Does that make sense? Any questions? Not the most. Yes?
You want to have both get and set. Is there a shortcut for that?
Both get and set.
Yeah.
And this, to have the same method?
This is kind of verbose.
Sure. Like if I did get name and set name? But they're sort of, they could have different behaviors. So when I use the get, I would be looking or retrieving some information, probably returning that. The set operation probably has a different function body at that point. There is no shorthand to consolidate those or do any sort of two assignments in one property. Yeah.
Is there polymorphism? Can I pass multiple arguments and define the same thing, and like he's saying, overload set with get and have a single thing which depending on the type of variable I'm passing in?
It sounds like it would be just inside of the method that is your getter or setter. Is that correct?
So in Java and C++ and what have you, you can define the same function name, but give it different argument passing. I just wondered if that's called polymorphism. Is it present in?
I don't know if I entirely follow, but this is more, I think the features that are sort of exemplified here are like just key value sort of examples. That sounds like more of, the polymorphism is more of like conceptual, how does my programming kind of like work, but.
It's typeless still. Okay, so.
Thank you. Cool. Any question?
Just curious. This may be ahead of the application.
Sure.
Do you know how compute properties work with like D8's monomorphic versus megamorphic calculations?
I don't. I'm not familiar with that actually.
Okay.
Yeah. I have to look deeper, but. Cool. So, and here's, if I forgot to mention this, up top you'll see import assert for a lot of these, basically just importing the assert function from node. It basically throws an error if it's false. So just assume that anything in here is true. I'm basically just showing examples of like what the operations here are, and those will make more sense as we look at different examples. But in a lot of places you'll see console log, and that's just, I'll build the file and we'll look at it and see what actually happens. So, okay, cool. Let's move on. Next we have let and constant. Is that right? Anybody okay with that? Anybody not want to hear about that? Cool. These are particularly interesting. Oh, I had a slide. Man, let is the new var. How many have heard that? Like, I saw that written everywhere. I was like, why are we writing that everywhere? So there's something important about let, and that is that it is block scoped. Typically in JavaScript, we are entirely used to function scoped arguments, like var would hoist itself anywhere. If you placed it anywhere in a function closure, it would hoist itself to the top and at least just exist at the top, whether or not you assigned it later or used it at that moment. And it is available outside of that block. And this is the block right here. Now, if this was a function, that variable would not be available outside of the function. It's private to that function. It's enclosed. It's an enclosure. But what we find with let is that it is not available outside of its block. So what you get is much more meaningful blocks in your code, and you don't leak variables outside of the blocks that they're supposed to be in. When I define let name inside of this block, I'm really just saying this should not be used outside of this block. Maybe it's an iteration. Maybe it's an if statement. I couldn't tell you how many situations there are that it would equal a block, but it behaves entirely differently because once you're outside of that block, you can no longer use that variable. It's not declared. So,
is that useful for I'm sorry.
Can you use the same name outside of the block? It's like, sure. Sure.
So if you want to have another variable in another block called name, do that, or redact it, or I don't know what you're doing, you're going to use that one.
Yeah. That would be fine. Similar to if you were in strict mode and you declared a variable twice. If that variable is still in scope of the second place you assigned it or declared it, it would throw. In this case, using let in the same block will throw. But outside of that block, the variable no longer exists, and its name is not in the namespace anymore. So you can use it again. You can let again. And that's really useful, like where we'll see like iterations. There is an example, but the common paradigm is I'm looping over with an iterator. It's the same function closure, so it's the same scope for variables, but on each iteration, I'm sort of just reassigning the variable. So you have some tricky situations like that. This helps because I just declare it once, and inside of that block, it's ready, but the next iteration, it's a new block. It's not the same. So
can you use this? I mean, you mentioned iteration, so all the times that you're doing a for loop and you're just like var I equals 0, you find yourself when you're doing nested loops and stuff like that. Would I then be scoped to the parent block, or would it be available in the child?
It's a great question. I'm pretty sure that the block scope was the same as the closure, so that if you declared let up top, you had 7 nestings of blocks. You're still in the same scope.
Okay.
The variable is still available to you, so declaring it again or using it. You can assign it again, you just can't let it again. And there will be an interesting example that might explain more there. So the more technical way to say this is var is function scoped and hoisted. And this example would kind of indicate that. This is a lambda, but it's a function. So inside if this is a closure. If I declared name down here as a variable, it still gets hoisted to the top of the function scope. Now it doesn't get assigned until this line, but it's not going to throw an error that the variable is undefined. But after it is defined, I get the value I'm looking for. Now let is not hoisted, and it is not function scoped, it's block scoped. So that's actually not the right example. But if you did let name, this would throw up here. Cool. So constant is the other part of that, and it's very easily summed up. Constant creates an immutable primitive. If you stored an object on constant, you couldn't reassign that constant. I could never go var equals 1. But if I stored a constant, an object at a constant, that object itself is not immutable. It just means that I can't reassign var at any point. Does that make sense? That's a good question. I'll save Googling that for the end, but did someone have an answer? Oh, yeah, in this case. As far as, I believe it's block scoped, but I'll look that up actually. It's a good one. Great, so there's another situation that's sort of tricky here, and that's that the difference between, well, I'll put it this way. There's a concept called a temporal dead zone, and that plays in when we're looking at the order of things defined. Now, the important takeaway here is that let existing or not is not a matter of which line it's on. We discussed earlier, if you let something, it wouldn't be hoisted, so if you tried to use it beforehand, it wouldn't be there. This is kind of different. What we're saying is even though up here, I can declare a function. This function is not going to run yet, but I'm going to use the local variable. We declare it later, but this won't throw unless I try to use it before I actually define that. So this distance between when we declared the let variable and when we declared using it somewhere in our code is called the temporal dead zone. And in true like ES6 specification, if we tried to use that function before we actually let the variable, the function would fail, right? We didn't let it. It's not line-based. It's not sequentially line-based. It's time. We didn't set it yet. However, in Babel, this is one of the features that's extremely difficult to emulate because variables are hoisted, and if you don't actually have block scope variables, it's not easy to sort of emulate something like this. So what you'll find is if you do something like this in Babel, Babel won't throw an error. But if you were actually moving towards an ES6 engine that had let and constant, you would have a problem. So yeah. Sorry.
If they had a let local in the outer scope, and you ran put string before the second assignment,
Mm-hmm.
how would it value?
To the one that was first defined. Yeah. Yeah. I have a feeling that the dynamic type and very like confusing features that if you've learned JavaScript and you didn't learn Java or C# or anything before that, you kind of just take them for granted. You're like, yeah, that's how it works. But they're definitely like paradigms from other languages that sort of go over my head sometimes too. So.
Yeah, that rather comes in the about family languages, and that put string would definitely flow for local.
Gotcha. And I think this example was pointed out in sort of a lot of guides and stuff like that, and that may have been why they thought it was important to mention. For people that are moving towards this, if you see let, it's like, hey, it's not actually what it could behave like differently. So yeah, and so hoisting, this is as trivial as I could get example of sort of the hoisting issue we were talking about and the iterators and things like that. Oh, sure. Yeah.
So can you shadow with let? So his question was kind of based on the assumption that you could have a let, whatever the variable was there, let name.
Sure.
Be in the outer scope and then redefine it in the inner. Is that actually
Mm-hmm.
possible?
Yes. Yeah. The variable itself is, for all intents and purposes, the same variable that you're used to in JavaScript. It's just
Put string would change definition.
yeah. Mostly, the most paramount parts of that are just like the point it becomes a null reference, basically. So here's some ES5 code. Just break it down. There's
You can shadow it then, like so if you take 300 boxes and back out of it, you can go back to the original value.
I see what you're saying. I believe so, but I can't confirm that actually. Yeah.
So Josh,
Yeah.
can you repeat the question back?
Oh yeah,
Because
sure.
there's people online watching.
Oh
They
sure.
don't know what the questions are.
Can they hear me through this? The Mac?
Can they hear?
Where's the mic for them?
I don't know, but it's from your box.
Okay. All right. Cool. So here's an array of ingredients. We're going to iterate over that array in the classic ES5 style. We have an iterator variable I. And each iteration, I want the ingredient from the array. Then I'll set a timeout, and after a certain amount of time, I will log the value of that variable. Now, if you're like laughing at this example, it's because it's going to print out Nutella 3 times, and that's because of shadowing. Because if this variable gets defined, written, and I guess it's not technically shadowing, but by the end of this timeout for each of these, the last thing it did was assign the ingredient at the last I to whatever the last thing was. So the closure that captured the value of ingredient is going to be used in every function that was used here. It didn't necessarily capture the value; it just had the same variable enclosure, and the variable itself was overwritten. So the sort of like the reason I think people are interested in saying let is the new var is because in almost every sense, it kind of protects you against things that you might not realize you were doing in situations like that. Where if here let ingredient is scoped to the block, by the time it gets here, we have what we were expecting. I should probably comment that out. Does that make sense? Yes.
So is that a suggestion that you should make, because the best practice you should
That sounds like a debatable topic. I think.
Well, I guess what's your opinion?
Yeah, I think. I mean, you obviously need to know what you're doing, and I think the troubles and the confusion that comes with declaring with var are often overlooked and not easily like readable. So it would make no sense to not be more tidy than necessary. It seems like when you use var, the function scope can be big, and the function scope is dynamic. Like you could be leaking variables somewhere. You could be, I don't know how many problems you could run into, but I find myself, understanding what's going on here and saying, why would I not use let? Like, it seems more appropriate to scope things to my block. But there's definitely still situations for var. I'm probably not the best person to tell you how many places both would work. Yeah.
So was that creating your closure, you're saying your bounds and
It's not technically a closure because only the let is sort of scoped to that. So blocks haven't become closures, but the let and constant sort of mechanisms have allowed those variables to be scoped to that. Does that make sense?
So they're being handled separately then for the normal namespace that we create?
Under the hood, I'm not sure what the actual implementation is. We good? Cool. All right. Oops. All right, arrow functions. This is also pretty high on the doodle list. A lot of people are probably thinking, that's a lambda. This seems to be what everyone likes to talk about as well. So arrow functions are obviously, at first glance, wow, a really shorthand for functions, like a macro. But they do behave slightly differently, and that's the important part, and that's why I think they're associated with lambdas. Here's the most trivial example of ways that you would replace your function calls with, with an arrow function. And that usually takes place with, I don't know, mapping or identity functions or, simple things. Here's another example. What you'll see the most is like, I want to use an arrow function for my mapping and for my reduce and things like that. Becomes much less verbose for me, when I write things like this. Or map over something with a function definition and things like that. Plus you're, a lot of overhead there. But what I want to show you here is like if your expression for this arrow function is one line and partially simple, it fits on one line and there's no need for the brackets around the function body or the arrow function body. Similarly, you have one argument. You can kind of just splat it there. It doesn't need its own parentheses. It's pretty friendly. As things get more complex, obviously, if you're returning an object, you would have to put parentheses around those brackets and things like that. An important other thing here is when you have a one-liner, the return is implicit. This one-line expression for my arrow function will return that object for me. There's no need for a return statement. If you do, it will probably throw. Similarly, with one argument, no parentheses needed here. But you might see this written, like that. There might be style guides that would dictate that as well.
Is there a way to have a no return? You know what I mean? Like, what if you want to just call a function that operates
Sure.
on some closure?
Is there a way to not return anything? Yeah. I mean, the way that you'd have to do that would be to break your arrow function to an actual body with brackets. At the moment that you drop those lines, well, I guess they're an arrow function. It's be something like this. At the moment I do that, this no longer returns for me. So it's now an explicit return that has to happen. However, being one line, it just does it for you. Does that make sense?
Yeah. So if you left it one line though, but put the brackets, it would still return.
If I left the one line.
Yeah. So if you just
and
drop
put,
that in brackets, would that
sure.
return?
Let's see.
A value, or would that be?
613. Oh, I lost my line numbers. Well, let me back out.
I would think if you put the brackets on there, it would act if it was multi-line because you still have to deal with identification, right?
I think it's Yeah, I think it's safe to say, I didn't know the exact answer to that, so I'm running it. I think it's safe to say that, yes, adding the brackets then made my implicit return disappear.
It's the brackets, not the long space.
Sure, yeah, but yes.
It's joking because that's not an expression. That's not a statement. That's an expression. So you have to.
Okay.
So
Gotcha.
get something other than that integrated in that term.
Sure. Gotcha. Does that make sense? Did that answer the question? Yeah. Cool. So yeah, like we were looking at now, just having its own small ternary here, returns automatically. It's a small, tiny little function that's one line. Fits easier. And here's just an example. Like I thought this was, it kind of just stood out as really telling of the amount of syntax that you don't have to worry about so much anymore. You have so much less to write, and it's not a huge deal breaker. That's not the most important language feature, but at this point, like it gets annoying. So cool. So there's a couple more important things here, and I'll do my best to explain them. Basically, the difference with arrow functions and normal function closures is that when you create an arrow function, this context is lexical, whereas this context for any function that you just declare that has its own closure is dynamic. It can be bound, it can be called in a different context, so this argument can be passed to it. So here's an example of that. If I had inside of this function closure two set timeouts that created a function closure itself and tried to call to this context and read the variable, and one that uses an arrow function and uses this context to assert something. Now, both of these asserts are true, so what we'll find is that, as you might have expected, this anonymous function here does not contain or bind itself to this context that it was defined in. Yes, there is a closure. In typical ES5, you might find yourself writing this equals this, or you're binding this function to this, because when it gets evaluated later, it has no binding. It's this context is dynamic. Does that make sense? Is that something that I think everyone's probably experienced? Great. So when you create an arrow function, this context for that is lexical. So at the moment I defined it, its lexical scope was that this was this here. By the time this runs, this will definitely be equal to 0. It's automatically sort of bound for you. It's really the takeaway. Does that make sense? This is super convenient, I think. You cannot, yeah. Well, there's an example kind of showing that, but since it is lexically bound, and arrow functions have their own sort of, protocol, if you can call it, it has a call method, but this context cannot be changed after the fact. So obviously if I ran that, it would be true, the assertions are fine. So here's a little bit closer to what maybe you're asking. This is sort of just a naive implementation of, let's have a bind function. Let's pretend we're in the world where the bind function doesn't exist on the function prototype, and we have to make it ourselves, like the underscore library or something. So I'm just going to declare a function. It takes a function. It takes an argument to use this context. It returns a function who gets applied with the context I wanted and the arguments that I passed. So in normally ES5 land, that's what it looks like. It's kind of verbose. In ES6, here's my bind function. How about I just take a function, a context, and I return this arrow function. And inside of that, I'll take the function you originally gave me and apply it to this context arguments. So just verbosity-wise, those are the differences. If you actually get into what's going on here, this context right here, I'm just going to declare an anonymous function and return this from the function body. So this has no binding. It's going to return this context of its closure. This context here is going to be lexical, and it's in brackets. When I bind each of those functions and give it a context, the one that was created with this closure returns exactly as I would expect. I called apply on it. I gave it an object to use this context, and what it returned to me was the context that I bound to it. Now, the lexical context, you can apply or bind or call to that arrow function all you want, but at the point that you return this, when this arrow function was defined, it captured the lexical scope of this. And when you use that later, it's still going to have that capture. And the apply sort of doesn't do what you're thinking it's going to do because of this context won't be changed.
So based on my previous question, that should work though, right? With the brackets on it, shouldn't it just be error or arrow this?
Sure. Let me just build this file real quick just to make sure everything was up to date and not broken. So the last time I checked this, the lexical context was captured no matter what. Now we've obviously just discovered that the brackets being there, even if it's a single line expression, is sort of doesn't matter because using the brackets implies that it has a function body now, so to speak. And this context is sort of a different issue. The existence of the brackets doesn't create a closure versus an arrow function. It's still the arrow function which captures the lexical scope. So by the time we call it and apply it or whatever, still has that captured one. Does that make sense? Cool. Any questions?
How do you pass a variable to the scope of the second function?
How do I pass the variable to the scope of the second function?
Yeah,
which is the second?
Function.apply CTX, so you're using the variable from the previous scope, but is there a way to pass a variable specifically to that scope, or is it all available?
You're looking at this right here?
Yeah, that line.
So in here, I'm creating an arrow function that returns another arrow function.
Right, so if you wanted to pass a variable to the second function,
This one.
would you just do like another equals?
I'm not sure I follow.
So you have bind equals func CTX
Mhm.
arrow, then you have a function, arrow function.
This
If you
one.
wanted to pass, yeah, so if you
Okay.
wanted to pass variable to the second function, the nested function, how would you do that?
I mean, you can give it as many arguments as you would like and use them, in the next arrow function. Is that what you're saying? I mean, what's happening here is like this is being returned. So when you call bind, I'm returning a function to you. That function, I mean, yeah, it could take arguments. Those would be available to this function body here. Does that make sense? I don't know if I'm answering your question, but okay, sorry. All right. Cool, and that's what I have on arrow functions. So moving on, classes. They're not even classes. There's quite a few people that would talk about the ES6 spec and be like, oh, the worst part is classes. Just classically speaking, what people mean is that these, there never actually been classes in JavaScript. It doesn't have the inheritance chain or the ancestry that your classical object-oriented programmings have. Now, I won't get into how the object prototype works, but how we emulate class inheritance in JavaScript is the object prototype and prototype chains. Now, if this looks familiar to you, it's because it's basically the fundamentals of class extend sort of behavior in ES5. This idea, I think, was popularized by John Rezick, who was the author on jQuery, and wrote his own class extend for certain modules. Then this became something that this, I think, is taken out of Backbone, and how Backbone offers you the extend, this Backbone class-like object. And what you're doing is creating a prototype chain. So this is kind of verbose, but fun to read through if you're curious about how that works. And essentially, since this has become a staple in any sort of like object-oriented framework, like Ember, Backbone, and things like that, we're really kind of tired of writing it. It makes sense that there should just be a way to include that without having to write this library or include it everywhere and have it for my own library. So what you'll find is that essentially it boils down to sort of like a macro. Nothing is different about declaring a class like this than declaring a constructor and giving it a prototype and using that to create a prototype chain later that extends an object. But it's obviously better and simpler for me to write just class animal than to have to worry about a class extension and worrying about the constructors on every prototype being correct and things like that. So what you'll notice here is like the object literal sort of expressions that are available to us are also available here. One that we haven't seen yet is static. So you can define sort of methods on the constructor object itself, which would be available as, you know, something like animal.mate. The rest of these become prototype methods. They're put on the prototype of this constructor, and you can still use new to construct, and it would behave just like you expected it to. However, you have one awesome feature, and that is that I can now use super on things. And inside of my methods, if I had a superclass here method, it would be super.appear, and I could call my supers method in this context or whatever. Does that make sense? Does this look like everything you're probably familiar with? Yes?
You can tell me if you're going to cover this in a minute, but the constructor up there,
Yes.
what's the genus protozoa? I mean, is that defaulting parameters or?
Yes, I'm sorry. Yeah, I tried as much as possible to not use things that I'll cover in a little bit. But yeah, this is a default. Yeah, no, I mean it's great to point out. I'm using a default value for the parameter that's accepted by the constructor function itself. What you'll also notice is that this is my top level class. It doesn't extend any other classes. So in the constructor, I can do whatever I want, so to speak. The same rules apply. If you were to return an object from the constructor, you would be overriding the constructor, and that object would be returned. That still exists in ES5 today. I don't think that will be too confusing, but I don't have to do anything special in this constructor. But if I did extend something, I would have to call my super, and we'll talk about that in just a second. But here's my animal. Was there another question? Everybody good?
Static methods. If you were to put this in there, would it be a syntax error, a runtime error?
That's a great question. What is this context of a static method, basically? Yeah. Let's try it out. Web console logging is not a bad idea. It's the constructor function. Someone say that? That makes sense. I actually wondered that today myself. I was like, wait, what does static methods have in this context? It would be handy and obviously expected if it was the constructor itself. Mates. I don't think I need those other ones. Kind of okay if it throws. Well, so this is really a static method, so to speak. Let me hold on one second. So function animal, right? So this context of my. Sorry?
Is this going on?
No, it was just because I didn't give it arguments, slightly different. But someone was asking what the static method was. So imagine you create a constructor yourself in ES5, like function animal. There's your constructor function, here's your function body, blah, blah, blah. If you were to say animal.mate, you could define a function there. Obviously, a static method is not available to any objects that extend the prototype of animal. So if you called new animal, you wouldn't be able to call mate on that. It's a static method that lives on the constructor object itself. So this animal class, we'll call it, is an object, a function constructor. And by using static mate, it's really just applying those and shoving them onto the constructor as a property method. Does that make sense? Cool, everyone good? All right. So I made a bunch of these ridiculous classes, mostly to just play with ASCII art. But here's one thing I want to point out. I said I would mention this. So this is a class called octopus that extends animal, right? When you declare a constructor in a class that's extending, you must call super in your constructor before you can use this. So had I not called super there, it's not up to me to declare those first and call super later. This will throw. You have to call the constructor's constructor, the superclass's constructor, before you can use this at all. And Babel supports that. You'll find yourself with an error if that happens. So cool. I actually haven't played around with that, so I'm not sure. But from the specification, sort of like hard rules that I've read, it only mentioned this. So I think it makes sense that it would be up to you if you weren't using the object itself. Right. So this .name revealed a syntax error.
That's the reason that's not innate. Calling super then is because of performance. You can choose to redo some non-element or non-object specific functionality in constructor, and then do super, and then start defining.
Sure. Yeah, I mean, from the optimizer's perspective, it definitely it has implications, I guess. Yeah. So here's my alligator. It's much worse. I won't tell you which one I made and which one I stole from the internet. I'm an artist, okay? I'm working on it. Oh, that's a good idea. It's actually a smiling alligator. So here's just some examples and some assertions. Protozoa equals new animal. Protozoa appears. This is my prototype method that I find. If you want to assert that the prototype of protozoa is the animal prototype, the constructor.prototype property, that's still true. What we're finding is like classes aren't really different than what we expected before. It's still the prototype chain. Everything behaves the way you would expect. The instance of operator still returns true if the constructor exists in the prototype chain somewhere. So in this case, gator being a new alligator, still instance of animal, octopus, instance of animal, etc. And there's just a ridiculous example of how I had to get through writing these. Cool. Does anyone have questions about some of that up at the top? Implement interfaces.
You like implement some interface that says you must define
I think I'm confused. I'm not sure the answer to that question.
like, you know, how Java has that, action script has it, right? Define some interface, and if I implement that interface, I've got to define method. All methods the interface.
Oh, I don't think there is a corresponding feature like that. Yeah.
Java has more sophisticated class definitions, including inner procedures and.
Sure. Of course, yeah, and I think that's that's the takeaway from this expression, which is kind of funny, but it is still true. These aren't any sort of classical classes like you have in Java or even Python or something. So what we're really looking at is a macro, right, for creating classes, creating prototype chains, which is handy. It's really handy, but there isn't sort of any new or interface sort of functionality that's introduced here.
By the way, have you tried to create inner classes and pass them back as class definitions to functions that might do them? Is that support in ES6 or?
If I understand you, can you pass around a class?
Well, inside a class, can you create another class called an inner class? And pass
sure.
it back
Sure, I understand, but I don't. No, that's not supported. Basically, what you see today, it's kind of the object literal sort of expressions that you can put in there. There's no sort of meta programming that you can do inside of the class definition block. It's kind of just straightforward. It's kind of a macro. I think that's what to expect from it. So, any other questions? Cool. All right. This is one of the most interesting things, and perhaps the one that will be most far-reaching in the whole ES6 spec. It was also high on the list of the doodle poll, and I thought that was great. The iterator and iterable protocol is sort of something new that will be given in ES6, and that is the iterable protocol is going to be used to describe something that is iterable. An object is iterable. I can iterate over it if it implements a property method that is stored at the symbol.operator. Now we'll talk about symbols if we get to it, but just suffice to say the symbol.iterator is a special symbol. There's no string representation of it. It'll be accessed like that. So what this means is, before we talk about what forms of iteration we can do on iterables, an object can only be iterated, and it is an iterable if it implements a function that returns an iterator, and that function has to be stored at symbol.iterator. Now, some things are already iterable today, right? Strings, right? What you'll find is that it's slightly different than in ES5. Strings today you can iterate over with for of, and you can loop over each item in that string or each item in that array. The methods in ES6, there is another loop introduced, which is for of. I'm sorry, for in. I should probably just look at this. Sorry. Right, so the for of loop will give us the ability to iterate over objects that are iterable. And it's slightly different than the for in loop. We're used to the for in, it's fine, it works, but now we have this whole new interface for iterating over things. And that is far reaching because it has a lot of objects that behave that way, new objects that behave that way, And it's honestly just constraints that you can like sort of boil down and identify. So I said the word iterator a lot, and that means that like when you have an iterable object, the function stored at symbol.iterator should return an iterator. And this iterator is a separate thing, right? So I have an array. That array is iterable because that array has a symbol.iterator property method, and it returns an iterator. That's all I need to know from the iterable side. And the iterator itself is an object. It implements a property method called next, and that's how it gets iterated over. It returns an object that has a done property and a value property on each iteration. If you don't return these things, things break. And invoking iterators has a few constructs that we'll look at right now, and then when we look at spreads. But essentially, if you used that symbol.iterator on an array and asked for and called that function, you would get an iterator back. And this iterator object, you could just call next on it a bunch of times, and you would get the result of each iteration. Now, if you're noticing, like that's obvious, it's lazy. I have control over it. It's different than what we have today. And there's a lot of objects that implement iterators. You know, it'll return an iterator for something, and that has a lot of different forms. So let's look at the code. All right, so here's the simplest example. Here's a string. For let letter of some string, when I build this, I will get, well, I won't look at the console log, but each letter will be spit out. And that's because when I say for of onto this object, what it's going to do is look for a property method stored on the key that is the symbol, the iterator symbol. And it will return that function, and that function it will call next on over and over and over until the done property in that object that it's returning is true. So this string automatically returns an iterator that will return an object that isn't done until you've covered every letter in the set. So right here, if we look at type of some string and access its property symbol.iterator, we get a function. And that function is actually an iterator function. It'll tell you that, the constructor. Similarly with an array is also iterable. Those are the obvious ones. The symbol.iterator property is a function. And we'll look at this closer, but if I wanted the symbol.iterator of that array, let's look at that. I would be able to call, well, I'll call it as a function, and then I would be able to call next on it. And each time I call next, I get an object back that has value and done. What's the value for this iteration? Are you done? And that's how it works. These construct iterators, the things that are built into the language like for of, or the spread operator like ... those iterate on it until it's done. You don't have control over those, so to speak. It's just going to keep going. It's going to iterate next until it's over.
Can you break out of those?
It's a good question. Let's test it out. Yeah, you can. Yeah, I think it follows a lot of the same rules as your for-in iterations and stuff like that. The block can still be broken. So that's the basic. And here's some more interesting things. I'll try to, this looks complex. I tried to be as simple as possible. But now that we know there's an iterator protocol, an iterable protocol, we can kind of create our own objects that iterate, right? And we can use the regular language constructs like for of to iterate over that thing. So here's an object. I'm just going to create an object literal, and I'm going to make a property method that's keyed at the symbol.iterator. And inside, I'm going to create a closure. And I won't be dead yet. I will return an object. Now this object right here, let's simplify it. Like all I'm returning is an object that I'm going to call an iterator. And it's an iterator because it implements the next method. That's almost all there is to it. So here's an object, here's a next method. JavaScript is okay with you giving this as an iterator because it implements next, and that's some of the only requirements. So when it calls next, I am obviously not dead the first time, so I will die, and I will return value and done. And since I return done false, it's going to iterate one more time, and then I will return done true. So what I get out of this is only one statement, and then it's done. And I did that by the language construct for of. I'm saying, let's iterate over this object. JavaScript is going to handle grabbing an iterator, calling next on it over and over, and checking when it responds that it's done. and those are the amount of iterations I get for this block. And whatever's returned by this value is what I get, assigned in my expression here. Yes?
So in the for loop, you have let quote is what you're on right now.
Sure.
Would you ever do something, would you ever not use let in that spot? Are there other things you could do there?
Would I ever not use let like right inside my iterator here?
Yeah.
Yeah, certainly. I'm not in the habit really of writing like var here and let inside of like iterator loops and stuff like that. I think it's a stylistic kind of thing. Usually, it's the same as when you see a for loop that defines var I in the midst of it. I thought that was a macro. But for var I equals 0, I less than whatever. It's the same fashion. But in this,
It's convenient for after the iteration, examining the result of the variable that last assigned.
sure. And the important implicit things here is that when I define let above this, it becomes block scoped to the outer block or closure. And when I use let here, it is only scoped to inside of this block, which is difficult. It is a part of that block, even though it's not physically contained by that. Does that make sense? So by declaring let here, outside of this block, quote is not available. Oops.
Could you reset the head? Could you set it back to
That is something that could be handled by your iterator. If you were writing a custom iterator, the iterators returned by objects when you ask for an iterator is just a function that has state. So there is, so to speak, like a cursor for the iterator that you're using. And it has an internal state that is inside of the function closure that you don't really get to tamper with. There are iterators that implement more methods than just next, but I have not seen anywhere that a reset or reset the cursor or start over is something that's going to be there. I don't think it will. Yeah.
So while we're on the topic of for loops, a lot of frameworks implement their own for each. That allows you to iterate over an object and get all the properties and keys and stuff of it.
Mm-hmm.
Is that something that's going to be built into ES6 or?
Yeah, so the question is can I still use for each or should I?
No, the question is, can I have an object and use for each and not have to do if has own property, whatever it, will it give me just its own properties?
Sure, that's going to rely, that depends on the object implementing that method. Now, in ES5, arrays have a prototype method for each, and that is its own internal implementation. It's not necessarily part of the iterator protocol. So an array knowing how to for each and only giving its own elements is not going to reach into other areas. This would be entirely separate.
Well, I'm talking more object specific. So if I have an actual your typical object and I have 5 properties and values in there,
Mm-hmm.
Is there a way to do a for each on that and get property and key like you would in a framework? Do you understand what I'm saying?
I do. I think what that will turn into is use of the for of construct. I think I'd have to look at this.
So that would be the default behavior if you don't define your own iterator?
Well, it'll depend on the object's iterator method. What does the object iterator return? Its own keys or symbol properties or prototype methods and things like that. But I'm foggy on exactly what the object will iterate with. But what you'll find in a lot of situations is if you really wanted to, I think there's a lot of places where they'll do key of some object and I'm not sure. I wonder if we just Google it real quick.
Okay. Yeah, that's my question.
Yeah.
Because it seems like every framework, Lodash, Angular, they all have their own for eaches to do that sort of thing.
Right. So, what I'm foggy about is whether or not object literals actually have an iterator method. And I don't think that they do. What I've seen most often in ES6 is iterating over, let's say for quote of object keys and things like that. But I don't know for sure, but I don't think there is an object iterator. So that sort of functionality is super convenient, but I don't think that there's a drop-in replacement in the ES6 world. But you do get a ton of other like features for, arrays like entries and things like that, or using object keys, which is more or less the same thing without the overhead of function closure and assigning those variables and stuff before they're given. So short answer, I guess, no, probably not. Any other questions? Did I miss anybody? Okay. So does this example make sense? When I try to iterate over something with the natural language constructs, it looks for a function on the symbol.iterator that returns an object. And it's just going to peg that object with the next call until it's done.
The done equals true is key syntax. Is that how to stop? Or how to
Yeah. So every iteration, every call to next on that object, which is the iterator, has to return an object that has done and value. Value can be not present. That'll just be undefined, and the final iteration wouldn't produce anything. But yes, having an object that has a done key and the value is, I'm not sure if it could just be truthy, but true is definitely how it knows to stop. Now, if you didn't return a done true ever, you would infinitely loop. So.
What happens if you return a value and that value be iterated over, or would it be?
I don't think that it is included. We can actually test that. So this is going to loop over that. It's going to loop over until it's done. If my last iteration returns a value, my suspicion was that it wouldn't return anything. And there's some really interesting discussions around that. Where you'll find that most confusing is probably around generators. Generators are iterable, and when you yield things, they yield the iterator. But when you return something, it's not necessarily something that got returned in the iteration. The return value of your generator or your iterator at its last iteration is sort of ignored unless you know how to use it. Cool. So I won't go too deep into generators yet because I hope we'll have some time to actually talk about them. But a generator function is a function that is iterable. You have to call that generator function to produce an iterable object. But just to be confusing, the object that is returned is both iterable and an iterator. Sorry, it's just the way it is. Basically means that when you call .next on whatever's returned, I'll just write it like this. I said, all right, give me a generator. I have to call the function that returns gen at symbol.iterator of this. Oops. It would return this. That's all it's doing. Because this gen.next is a function. And when you try to iterate over something that's already, the generator's already instantiated, it's fine. It'll just return itself and you can keep going on it.
Since ES6 is getting very Pythonic, did it implement yield prompt?
No, I don't think so. Yeah, I've never seen that. So if we iterated over this generator, what we'd find is that every time I yield, that's sort of kind of like what we were doing when we returned a value and said I'm not done. JavaScript, internally keeps track of the cursor of this generator and says, did I reach the last statement in the generator? And if I didn't, it's not done. Basically, anything that happens here, this is the next. Next, oh, here's my value, but I'm not done. Next, here's my value, but I'm not done. And JavaScript will know that this is the last expression and that done is true after this yield happens and this rest of this code runs. If I return the value here, it's like we were talking about earlier, it does not get returned by the iterator. It doesn't get iterated over. But you can still access that value if you were driving the generator yourself, with a coroutine sort of library. That make sense? Everybody feel like they have at least a little bit of an understanding of the iterator protocol? Yes?
How would you access that value, that return value?
I think there's certain ways of well, you couldn't do that because then it would iterate again. There are ways of interacting with generators that include more methods than your natural just iterables have. Like next is obviously what it uses to continue the generator, so I can call it over and over. But the generators also include this interface for sending a variable in on the next iteration. So I can call send on that generator and pass in a value. I think, I remember reading this once, but I couldn't tell you off the top of my head how you actually get that return value. But it's something tricky than just not something that you should rely on. but it's safe to return because returning would mean it's done. Same as like returning a function. Does that make sense? Sure. But I don't know the exact answer to that. So yeah.
So is it a lazy evaluation? So let's say I am returning values in a loop where I'm doing some complex calculation, right? So does it go one by one? Value, let's say I'm doing I 1 to 10, right? So does it one? So it's basically, is it a lazy evaluation?
Yeah, absolutely. And that's why generators have garnered such attention in sort of like features or ways of, architecting frameworks and control flow or, async operations, because, as far as the iterator side, the natural language, like iterators that just keep going through each element in the set or whatever it is, those aren't sort of lazy. You don't have control over the iteration. But with the generator, if you really wanted to, you can call next as many times as you wanted and get just one thing from that, right? So this might be an example that sort of employs that a little bit better, but at any point I could stop calling next, right? And the function wouldn't continue, it wouldn't do more iterations. If it was an expensive thing, it would be great to have a generator for that, right? So here's a slightly different example. This is a generator function called lyric generator. Now, on its first iteration, it will yield stop. So we're gonna look at that. We'll just make sure we're up to speed here. I returned my generator, I called it, so I have a generator to work with now. It's not just the constructor-ish sort of function. Whoa, it did a lot of things. I thought I commented that out. Oh, all right. So I instantiated it, and then I called next on it. And next returned an object that had a value property and a done property. So what I get is stop. Why is it still printing out? Jeez. One of you knew this. Okay, stop, stop. So I yield stop on the first iteration. Now, this is where sort of, this is a very bare bones way, right? I want to call next once. Now, that could be your way of like control flow for a very expensive calculation in sort of a lazy iteration fashion. But just for the simple example, I'm going to call next and I get the first iteration. Now, the thing I wanted to display here is that when a generator is yielding and something else up top is driving it by calling next over and over, that generator can then basically hand off whatever it was doing to another iterable object. And the guy driving up top who's saying next, 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 will start calling next, next, next on the thing that this generator told it to. So in this situation, the first thing I'll yield is stop. Oops. Okay. And if I call it again, what do you expect? Does anyone know what would you expect to happen? Hammer time or H? The answer is H. Basically, this string right here is iterable, right? I can iterate over that string. And when I use this asterisk, when I yield, what I'm saying is yield, and here's the object to return. But I'm also yielding control flow to this other iterator. And now the top level driver of that iterator is going to continue what it was doing on that object that was iterated.
So that's like Python yield from.
Oh, okay. I'm sorry. I wasn't familiar. Gotcha. So this, whenever I see this, I'm like, I wonder how many levels deep you could do that, and why you would want to. But what you'll find is that's not exactly a foreign concept, because what you'll find with like the Koa framework, which is built on generators that does middleware that's generator based. What you'll find is that if there's one function driving, let's say an array of all generators, and those generators can yield to other generators, you can create this massive like control flow that's just completely the way that you want it to be, with upstream and downstream, with this is going to happen synchronously.
So that when that string is exhausted and you've been yielding you've been yielding characters from it, when the return happens or the done happens in the iterable on that, you return up to the previous iterable object?
It would then give back control. Yeah. So what we'll find if we go over the entirety of this, and this, let's call this the driver of this iteration. Let string of MC. It's going to iterate until done is finished. So we get stop, hammer time, can't touch this. Does that make sense? It's like kind of at a high level, like make Clear? Cool. And generators are just an amazing sort of feature. A lot of people will comment on them by saying like it's not that important, doesn't really solve the problems that we were looking for, but it's still cool. I think some of the major, I'm glad someone pointed out like lazy evaluation, because that's clearly one of the most like appropriate uses and probably the most common. Cool. Anybody have questions about iterables or iterators? Yes.
What happens if you throw the function star but then don't put any yields in there?
Don't put any yields. Well, linters will be mad at you. They will tell you every generator function must have a yield. But I mean, it's not required, and there's no, like in strict mode, it wouldn't, I don't think it would throw or anything that you didn't have a yield in there. Yeah, in today's world, you can use generators in like Harmony flags of Node, and IOJS has them by default, and I think even Mozilla Firefox has it. You don't have to write it in there. I've never seen an engine throw on that yet. So, any other questions?
You want to do? Can we? What do you have left? I just want to.
Yeah, sure.
Time here.
So we have. I can look at the folders actually.
Only 60 pages.
I've got destructuring. I know. Destructuring, default rests and spreads, generators, proxies, which includes like reflect API, symbols, and then maps and sets.
Does anybody have a strong feeling towards any one of those? No.
Well, did you have an example of the send into the generator object?
I don't actually. Yeah, I'm sorry. There's a lot of interesting work there, though. I'd look at a library called Co. Some really smart guys have developed a lot of really cool features in terms of coroutines with generators and things like that. I don't know that the send is used that often, but definitely in the lazy sort of iteration, it becomes like.
I've used it for dynamic programming.
Oh wow. Okay.
Proxies or send, or proxies or
yeah. Let's do
proxies.
Let's do one more, and then.
Sure.
Sorry to.
Oh no! I knew this would happen. I tried, but there's a lot to go over. Okay, so proxies. I will do my very, very best to explain this, and I'm sorry if I miss things. Proxies are really exciting, and the concepts and the things that they solve are somewhat above my head sometimes, in that the main takeaway is we don't want to meta program on objects in JavaScript. It would be preferable if we had membranes and things to surround those to be like isolated from actual meta programming. It'd be nice to have receivers and handlers in between. So let me just show a little tiny terrible diagram of what this kind of looks like. So proxies are objects. You'll see a constructor called proxy, and that'll help us create them. But essentially, when you construct a proxy, you give it a target, and that object is going to be the object that's hidden by this proxy. When we get a proxy object returned, that object is an intercessor for the target. Basically, anything that I send to that proxy, the handler can trap before it gets to my target. So these, like the terms are often like far removed from, they're just objects in most senses. Let's look at what it looks like to construct one of these. If you had the proxy constructor, you could create a new proxy by saying proxy equals proxy. Here's the object, the target. Now this is the object that's going to be hidden, sort of interceded with. I could have sensitive attributes on that. I could want it to be enforced. I could want it to be hidden from certain method calls. So what I want to do is give it a handler, and this handler can trap operations. Now these are sort of different than any like construct or property methods or keys or internal methods. What you're trapping here are the sort of like JavaScript methods to act upon an object. It's sort of like, using like send in Ruby or something. It's sort of like at the meta level, I would actually like to get a value from this. And when you call a function or you iterate over something, like every step of that uses a get. Hey, get this property, get the function at this property. Setting is similar. How about this one, like delete property? When you call delete, which is like a language, like the operate, I want to delete, object prop. How would you trap that? That's what this solves. Like when you want to trap the operation of deleting a property from an object, that's where proxies come in. I can have an object receive that delete request, intercede, and know what to do with that, or do something differently if I wanted to, before it even reached the actual target. And the target is what I'm protecting, so to speak, or disclosing.
So somebody asked about Java interfaces. This seems
like a methodology for implementing an interface.
Yeah, I mean, what you'll find is like enforceable objects is like a popular example for this sort of thing. Obviously, you know, JavaScript has safe method access for things, properties that don't exist. With this, if I trapped a get operation on my target and I said, if the property doesn't exist, throw, I could make this enforceable object. Hey, throw if the property doesn't exist. And I mean,
So
there's a
the
lot of
surrounding code doesn't know what type of object you're dealing with, whether it's a proxy or a actual class.
Well, that's
object or whatever.
that's probably the
It's-
yeah.
it's interface.
Right, that's the best part. Proxies don't really have the identity that you would think. They respond and sort of act in the same manner of the target. So it is this very like thin layer. Anything that you do not trap in your handler gets forwarded straight to the target. So it's this very, very lightweight layer that you can trap only what you would like to, and everything by default gets automatically forwarded to the target. So I just wanted to explain a bit before I dive into like what looks like too much code for this single example. But here's a function, and I want this function to take an object. With that object, I'm going to make a proxy, and that proxy is going to keep track of dirty attributes. This is like obviously just a naive example. When I call this function make model, it will return to me a proxy. Now that proxy's identity might as well be the model itself that I was expecting, the item that I gave it to protect or intercede on. And this is the method signature right here. You have proxy gets the target. The target is the object that I wanted to track dirty attributes on. And this object right here, the second argument is my handler. And it just defines, it's like an object literal. It has property methods. And those property methods are all defined and correspond with operations that you can do. Whether they're like new, you can trap that. Delete, you can trap that. Even if it's just, you know, accessing like prop, you can trap that. Almost everything that you'd want to, you can. So the method signature for trapping a set looks like this. I'm going to get the target because my proxy needs like a handle on the target that I was using, and that gets provided to the functions that trap. I will get the property. I will get the value that's being set, and this last argument is kind of interesting. The receiver in this case would be my target. I won't go into too much detail, but you could change the receiver if you wanted to, and that would mean like if the object had a getter or setter and it had a function for that getter or setter, you could change the context of this inside of that object as it's evaluating. But I haven't played around too much with that, so I won't say too much. So what I'm doing here is I'm trapping any set on this object, and if the object, if it hasn't been set already, I'm going to add it to this set and say these are the dirty attributes. And then here's another one. Here's just an example of what delete would look like. If I tried to delete a method from this plain JavaScript object, I would trap it. If it has a property, I'm going to add it to dirty attributes and say it's dirty. Now, the last thing you'll notice here is this reflect part. Now, the reflect API will almost always be mentioned in the context of proxies. However, the reflect API also gives you useful things like construct. And that's like literally something that you could use to take a constructor and simulate what it would be like to call new on that constructor. So instead of having some sort of haphazard or difficult to read way of using some of these natural language like expressions, you get the reflect API, which you could pass the constructor, and this would be the same sort of idea as what you would accomplish there. Or similarly, if you want to delete things like that. So the reflect object has safe methods for a lot of the operations that you're already going to do. A lot of them you'll find in object, like object define property. That's going to be implemented in reflect. However, the biggest difference is there is that when you use reflect to do it, it's not going to like throw an exception when you have like errors or you define a property that on an object that's frozen or something like that. You get, the way it's described is when using the reflect methods to accomplish those same things, you get a meaningful response, whereas otherwise you might get an error thrown. Go ahead.
Is there any difference between the reflect and the evoking the target's method directly? And could you do that? And is there a difference between those two syntaxes?
Well,
you said target dot, and did the set operation on the target.
Sure.
So within the object, is that equivalent to reflect, or is reflect actually doing something?
Yeah, it would be equivalent. It's going to do it the same way that you would in the normal way that you would write it in normal syntax, which is why those other things aside, I recommend reading about those. I won't be the best person to explain the other methods that reflect is used for. But if you're inside of a proxy, every proxy trap that exists, like set, delete property, all these things, there is a corresponding reflect method. And the reason that's important is because when I write this proxy method and I trap the set, if I want it to continue after the end, I don't really want to worry about how many things I'm supposed to be sending, like, target, prop. I mean, there could be things that go wrong. But the point is that there's this identical inverse interface for doing the same operation that you were trapping, and that is going to have the same name on the reflect object. So that's how that works. There's some more interesting examples. I found this, sorry? It's actually tricky. So there used to be, in SpiderMonkey engine, there used to be a method missing, sort of an unknown method or something trap. That doesn't exist in the ES6 spec. And what's most interesting is that when you call a method on an object and you were trapping get is the only way to trap that. And the fact that the method call is immediately after that is not something that differentiates the trap. So you could trap the get, and I think I played around with this somewhere, but in the trap for get, I knew it would be a method call. I could return a function that did whatever, but it is sort of confusing. There's no method missing sort of trap. But oh yeah, I wrote this probably when I was really tired.
Okay.
I don't know if I've even run it. Did it work? No, I mean, there's no reason it should. Yeah. I was like, oh wait, I just want a naive example, and then I was like, well, how do I get the dirty attributes? And I'm like, I've got to stop. You get carried away with some. And one thing I found particularly interesting, and this probably follows the interface sort of question that was mentioned on this guy's website, Tuality or something. He had this great example of making these enforceable objects for this interface that's like strong and throws when it doesn't exist. And basically what they were doing was defining this proxy. It had its own traps, and then you can use that proxy as a prototype of another object. And what he ended up doing was creating that proxy that was enforceable, that threw on methods or keys that didn't exist, and then he set it as the prototype, and then class extended that and just continued with objects that all, what's interesting here is that when you get this proxy down the line, like, it'll trap everything, and those prototype, calls hit the prototype. It's going to trap those. So you'll find there's really interesting ways of accidentally recursing forever in proxies. It's like all kinds of things you just wouldn't realize, oh, it's doing that. Like you're console logging a proxy and you're trapping the get. Well, console logging calls inspect, and it's going to look for inspect on every object that's returned, stuff like that. Here was a simple example I was trying to make, and that was if we had a class called OpenStruct, and for that we used as a prototype this proxy. What it does is it traps gets, and if the property you're trying to get exists in the target, we'll just continue. We'll just normal operation. If it doesn't, we'll create a new proxy that creates a new proxy when you call get. So you can just infinitely call properties on something, and they get created on the fly. So in this situation, let O be an open struct. O.name says, oh, that property doesn't exist. Let's return another one of these things, which is a proxy that creates things when they don't exist. So go on as many times as you want, and it's, we can trap the get and say, oh, get it, and return another one, and get it, and return another one. And then eventually, if you wanted to, you can create a class, set the prototype to something like that proxy, and then extend that class later and have this, interesting scenario. This great, meta level, programming constructs that weren't prior available. So proxies aren't available in Babel. It's obviously something that's very difficult to reproduce. What I'm using today is Babel Node and an NPM module called Harmony Reflect, which is probably the most work I've ever seen done on this sort of concept. Similarly, if you wanted a fully engine-based implementation, the latest editions of Firefox will have proxies, and I think they're fully compliant. So, yeah. Any other questions? Sorry, that was fast.
Yeah, it kind of reminds me of routing with security, making sure someone's logged in before it. Could use proxies or something like that.
Yeah, absolutely. I mean, I always think of things like that, and there's actually a proxy method called revocable, and it gives you like this revocable proxy, which you could call revoke on, and then it would immediately like stop working. But yeah, I mean, policies and membranes are sort of what is always sort of conjured when you talk about proxies. I think the difficult part is like there are a lot of comments around the topic saying if you think you need them, you probably don't. And that's when you're thinking of examples of like how to show a proxy, you want like naive things, and you're like, this is such a bad idea. But there are definitely instances, you know, like that this creates a great opportunity for, you know, enforceable policy objects and things like that, membranes, protections, and stuff like that. So, and logging, you know, trapping without meta programming around objects.
All right, so where do we get all of your great information?
Yeah, so I actually, all these code samples, if you hated them, I'll do better next time. If you liked them, they're available on GitHub. Where was that window? All the tabs.
I think I'm logged in on my Google account on one of those.
Okay, yeah, so I'll post both of these links. There's a link, there's a repository where you can find the code. Play around with it. I might end up changing it and adding more to it or adding more comments as the talk corresponded. I'll also post the slides link, which might not help too much, but this also has a couple links at the end, things I didn't cover, which would be important, concepts in ES6, and a collection of links that I found particularly interesting and some topics that are extra complex, which I think that these very smart programmers have done a really great job of explaining. So check out the links. I'll post this on the Meetup as well as the repo, and it's all public so you can get to it. So,
thank you.
Yeah.
Two more things.
Thanks for coming out. Just a quick housekeeping item. There's 2 trash cans. Glasses and things. We have